Uranus currently has 28 confirmed moons. However, unlike the 3 other non-terrestrial planets in the solar system, Uranus doesn't have moons that are as well known. Despite that, it has 5 major spherical moons. So that is more major moons than Jupiter and Neptune has. Of those 5 major ones, although not really famous, Miranda is still probably the most known one. Then going further away, there is Ariel, then Umbriel, then Titania, and then Oberon. So because these major moons are also largely unknown, they are going to be covered later in this video. But Uranus's other moons are even more obscure. Uranus's satellites can be divided into 2 broad categories: regular and irregular moons. Regular moons are the ones that formed out of the material that was once present in the protoplanetary disk that was orbiting around the equator of Uranus. That's why they are all right next to each other and have these mostly neat and circular orbits that have a low inclination, meaning they are orbiting around the equator. Uranus's 5 major spherical moons count as being regular. They exhibit the typical orbital characteristics of regular satellites. But Uranus also has 13 non-major, that is, non-spherical regular moons, and they are all inwards compared to the major ones. At least, that is what is currently known. So let's start by examining Uranus's closest moon and then slowly get to the moons that are more distant. The closest known moon of Uranus is Cordelia. It is about 49,800 kilometers away from Uranus. For some comparison, the moon is about 380,000 kilometers away from Earth. So it is safe to say that Uranus would engulf the view of the sky from the surface of this moon. As to what the surface of this moon looks like, we don't really know. This image was captured by the Voyager 2 spacecraft in 1986 during the flyby of Uranus. Only the shape of this moon was partially captured. The surface details remain unknown. This moon has a density of about 1.8 grams per centimeters cubic. This is somewhat close to the density of water ice, which is about 1 gram per centimeters cubic, and that does imply that a large part of this moon is composed out of water. However, a large part of it is also rock. Cordelia is very close to one of the rings of Uranus, so close that it influences the ring. It sort of acts as a container of the materials present in the ring, and on top of that, it very likely slightly pulls the material off of rings onto the surface, which maybe did lead to the creation of an equatorial ridge like the one that can be seen on the moon of Saturn Pan. However, we don't know that. Currently, Cordelia needs about 8 hours to complete an orbit, but this orbital period isn't permanent. There are indications that Cordelia is experiencing orbital decay, meaning it is slowly getting closer and closer to Uranus. That is going to speed up the orbital period, and eventually this moon is inevitably either going to plunge into Uranus or be torn apart, such that a new ring is created. After Cordelia, going outwards, there is Ophelia, which is only by around 4,000 kilometers further away from Uranus. The only photos of this moon also don't reveal the details of its surface. However, what they do reveal is its incredibly elongated shape, but the overall diameter of this moon is very similar to that of Cordelia. This image was also captured by the Voyager 2 spacecraft during the 1986 flyby. Most of the inner moons were discovered during that flyby. Ophelia has a much lower overall density compared to Cordelia. Ophelia has a density of about 0.87 grams per centimeters cubic, less than even that of water ice. This implies that this moon is likely very porous, so unlike Cordelia, it is much less so a solid chunk, but rather it consists of many small chunks that are most likely mostly made out of water ice with a bit of rock. Like Cordelia, Ophelia is also experiencing orbital decay, meaning it is also going to be eventually torn apart such that a new ring is created, or it is going to crash into Uranus. After Ophelia, going outwards, there is Bianca, which is a part of the group of satellites called Partia. So the group is named after the largest satellite in the group, which is, well, Partia, and it has a diameter of about 135 kilometers. There are 6 moons in this group, and they are relatively large asteroid-shaped objects with an average diameter of about 83 kilometers. The currently non-spherical moons in general that are around Uranus are significantly larger than the non-spherical moons of Saturn and Jupiter, but they are overall a bit smaller than the ones currently found around Neptune. Now, the reason Neptune and Uranus have larger non-spherical moons than Saturn and Jupiter could easily be because Neptune and Uranus are overall more distant, thus causing the tiny moons that are around 1 kilometer in diameter to be harder to detect. Besides that, it could also simply be the case that less effort was put into finding such tiny moons. Those two reasons together are also why Uranus and Neptune potentially have such a low amount of found moons compared to Saturn and Jupiter. Uranus currently has 28 confirmed moons, Neptune 16, and then Saturn as of recently 274, and Jupiter 95. And yet, despite these numbers, the gravitational sphere of influence, that is, the Hill sphere of Saturn and Jupiter, is overall less than that of Uranus and especially Neptune. So in at least one way, Uranus and Neptune have more potential to have a greater number of moons compared to Jupiter and Saturn. However, that doesn't mean that they do necessarily have more moons. Other factors besides the Hill sphere can heavily influence the overall number. When it comes to the Partia group of moons, one thing that is quite remarkable is how intensely crowded it is, with typically around a difference in the orbital distance to Uranus of around 2,000 kilometers between the neighboring moons of the group. However, Desdemona and Cressida have a separation of only 900 kilometers, one of the smallest known separations between two different moons of a non-terrestrial planet in the solar system. On top of that, it was also found that the orbits of these moons isn't exactly stable, so it is very much possible that in the future, Desdemona could collide with Cressida, which is inwards, but also with Juliet, a moon that is outwards. And this could happen between 4 and 100 million years into the future, so on a geological timescale, relatively soon. Now, because the moons in this group have orbits that are so close to each other, that is, when they are right next to each other, from the surface of each one, the other neighboring moon in the group would appear a lot larger in the sky than the moon does from Earth. In fact, from some of them, many times larger than the moon does from Earth. After the Partia group comes the Belenda group, which consists of Cupid, Belenda, and Perdita. The largest moon in this group, Belenda, at 90 kilometers across, was found during the 1986 Voyager 2 flyby, but the other two much smaller moons were not found in 1986. Cupid was found in 2003 using the Hubble Space Telescope, and Perdita in 1999 from the data gathered during the Voyager 2 flyby. So it was discovered from the flyby, but about 13 years later. Interestingly, Cupid and Belenda are two incredibly close moons, separated by only 863 kilometers in orbital distance to Uranus. This could eventually lead to a collision between the two moons. One study found that it could happen between 100,000 and 10 million years. Still, another study, made at a later date, concluded that the whole Belenda group can be stable on 50 million year timescales. After the Belenda group comes a single satellite. It doesn't really belong to a single group, and that is Puck. It has a diameter of 162 kilometers. It is the largest non-spherical moon of Uranus, at least as far as we know. However, it is interesting that it is still somewhat spherical. At least it appears to be so from this angle. Its density is about 0.8 grams per centimeters cubic, so less than that of water, implying that it is porous, meaning likely made out of chunks that stick together. The chunks are most likely just water ice mixed in with a smaller portion of rock. Water ice and hydrated minerals were detected on its surface. Along with that, it was found that it also has some dark substance that could be rock or some carbon-based molecules such as tholins that turn dark under the influence of UV light coming from the sun. This moon was also imaged at least relatively well, because unlike every other non-spherical moon of Uranus, on Puck we can at least clearly distinguish one crater which has a diameter of 47 kilometers. Interestingly, despite calling this moon non-spherical, it still does lean into the direction of being spherical. The low density of this moon could allow for a lower amount of mass, and with that gravitational force, to turn this moon into a somewhat spherical shape. However, it is still nowhere near as spherical as Mimas, a moon of Saturn which has a diameter of 400 kilometers and still holds the title of the smallest truly spherical object that is spherical due to its gravity. After Puck, going outwards, there is Mab. It is a tiny satellite for which we don't exactly know the size of. Right now it is set at around 18 kilometers, but it could be much larger if it has a dark surface, or smaller if it has a reflective surface. Overall, this is the most distant known inner regular moon of Uranus, and it orbits Uranus at about 97,000 kilometers. So it is significantly more distant than Puck, which orbits at 86,000 kilometers, which is also a lot more distant than Perdana, which is at 76,000 kilometers. Generally, the pattern for the currently found moons of Uranus is that the more distant the moon gets from Uranus, there is also typically more space between the neighboring moons. After Mab, going outwards, we encounter Miranda, the closest major spherical moon of Uranus. Miranda is the second smallest known object that is spherical due to its gravity. With a diameter of 471 kilometers, it is between the size of Mimas, which has a diameter of 400 kilometers, and Enceladus, which has a diameter of 500 kilometers. Both of these are moons of Saturn. Miranda is quite exceptional in that it has this very rare geological feature of oval-shaped regions which have a bunch of parallel valleys. They are also noticeably less cratered compared to the rest of the surface, indicating that this feature is younger than the surrounding surface. This feature could be a result of a subsurface water ocean freezing and then expanding, creating this pattern above. Possibly that water ocean is just partially frozen by this point, so maybe it still exists. One important component of an oceanic moon is differentiation, which means that the rock content is separated from the water content because heat separated the two, propping up the less dense water to the top layers while sinking the rock content to deeper layers. The indication is that Miranda is differentiated. However, the density of Miranda is about 1.15 grams per centimeters cubic, which indicates that it is about 60% water ice and 40% rock. So because the surface of Miranda appears to be entirely just water ice, that strongly points towards differentiation. One very odd thing about Miranda is its orbital inclination. It is unusually tilted at 4 degrees. Every single other regular moon of Uranus has an orbital tilt of less than 1 degree, but Miranda clearly sticks out. Yet still, it doesn't stick out as much as the captured irregular moons, which nearly all have orbital inclinations that are much more significant than 4 degrees. So Miranda is most likely a non-captured moon, meaning like the rest of the regular moons, it also formed from the protoplanetary disk that was once around Uranus. That's why its composition is similar to other major moons of Uranus. That's also why its orbit is prograde, meaning it orbits in the same direction that Uranus rotates around itself. Regular moons have prograde orbits. And its orbit is also quite circular, another characteristic of a regular moon. So it appears that something tilted the orbit of Miranda. After Miranda going outwards, there is Ariel. With a diameter of 1,158 kilometers, it is the second smallest major moon of Uranus, but just barely. This moon has plenty of canyons. As we can see in this image, the floor of these valleys is also smooth. This whole feature could be there due to liquid water freezing below the surface and then with that expanding, causing cracks in the surface above and also causing cryovolcanic activity. This moon displays signs of having a liquid water ocean even beyond the valleys. Most of the surface is just water ice, but the density of this moon is 1.5 grams per centimeters cubic. So in total, about half of this moon is water and half is rock. So because its surface is mostly water, that indicates that this moon, like Miranda, is likely differentiated. But besides water ice, other substances in smaller quantities were also detected on its surface. Specifically, carbon dioxide and ammonia. Both of these could be there due to outgassing, essentially a release of materials coming from the deeper layers. That is especially good news because ammonia acts as antifreeze. It lowers the freezing point of water, which could allow water to be liquid at temperatures way below 0 degrees Celsius, so less heat is required. On top of all of that, the surface of Ariel lacks large craters, indicating that its early solar system surface, where large impacts were common, is by this point erased because of geological activity, so its surface is younger than its formation date, which is 4.5 billion years ago. After Ariel, going outwards, there is Umbriel. It is larger than Ariel by only about 12 kilometers, so the diameter of Umbriel is 1,170 kilometers. The density of Umbriel is about 1.5 grams per centimeters cubic, so very similar to that of Ariel. However, unlike Ariel, it appears entirely geologically dead. It is probably the most geologically dead major moon of Uranus. Pretty much the only surface feature found so far on Umbriel is just craters, and very large ones, indicating that the surface is ancient. Although the surface of this moon is water ice, it appears to be the darkest one out of all of the major moons of Uranus, and it isn't known why the surface of this moon is so dark. Possibly it is covered by a very thin layer of some other non-water ice compound. Now, although overall very dark, in certain places, like the Wanda crater, which is 130 kilometers in diameter, on the floor of this crater there is something bright. Potentially that is uncontaminated water ice. Or it could also be carbon dioxide ice. This giant crater possibly acted as a cold trap which caused carbon dioxide, which sublimated from other parts of the surface, to solidify on the floor of the Wanda crater. Also in this single image of Umbriel, there is another crater visible, which doesn't have a bright floor, but a bright central peak. After Umbriel, going outwards, there is Titania, the largest moon of Uranus with a diameter of 1,578 kilometers and a surface area similar to that of Australia. This moon, like every other moon of Uranus, has plenty of water ice. Its density of 1.68 grams per centimeters cubic suggests that it is half rock and half ice, potentially differentiated as Titania shows signs of immense geological activity, particularly in this highest quality image captured of Titania by the Voyager 2 spacecraft. We can see extremely long and wide canyons. This moon also has a bit of carbon dioxide on its surface. However, on top of that, because of its size and mass, its surface gravity is probably just barely enough to hold on to some extremely thin CO2 atmosphere. After Titania, going outwards, there is Oberon. It is just slightly smaller, with a diameter of about 1,522 kilometers. Oberon is the second darkest moon of Uranus. It is also somewhat odd that, while being the most cratered moon, at the same time it exhibits signs of geological activity. It has canyons, but they are not as significant as on Ariel and Titania, which makes sense given that it has so many large craters. This moon is mostly geologically dead, and because of that, the chances that it currently has a water ocean are not that good. Potentially it might not even be fully differentiated, because we can see dark material, and that could be because underneath the water ice layer there might be simply a mixture of water ice and rock. But then again, it could be due to cryovolcanic activity, delivering something from the deeper layers. So it could still have an ocean, or it could have had one. This moon, like the other major ones, also has a density which implies that it is about half water ice and half rock. Its density is about 1.68 grams per centimeters cubic. So those were Uranus's 5 major satellites. All of them did not have their entire surface imaged, which is to be expected given that the images captured are from a single flyby in 1986. It could be the case that there is something very interesting going on the sides of the surface that weren't imaged. All 5 of these moons are smaller than the moon is. They all also have an orbital period that is greater than 1 day. It is between 1.4 days for the closest Miranda and 13.4 days for the most distant Oberon. they all are also tidally locked, meaning one side of them is always facing Uranus, while the other one is always facing away from Uranus. That is potentially why there are differences in the coloration and reflectivity between the sides that are facing away compared to the sides that aren't. All 5 of these major satellites are also either closer or more distant from Uranus than the Moon is from Earth. The closest major moon, Miranda, is 130,000 kilometers away from Uranus, and Oberon, the most distant major moon, is 580,000 kilometers away. After Oberon, going outwards, we encounter Francisco. As clearly visible, there is this massive gap of 3.7 million kilometers between Oberon and Francisco. Now, Francisco is the closest known irregular moon of Uranus, and typically what we find is this interesting pattern where for all 4 non-terrestrial planets, the outermost satellite is a major spherical moon, and after that major satellite comes a non-spherical irregular satellite, and that satellite is at the same time extremely far away from the outermost major moon. Yes, that gap is present for Jupiter, Saturn, and Neptune. That gap is even larger for them. For Jupiter, it is 5.5 million kilometers. For Saturn, it is 7.7 million kilometers. And for Neptune, it is 5.2 million kilometers. So even if there are currently unknown satellites with an average orbital distance that is present in that gap, it is still very clear that the area that separates the regular moons and irregular moons is the least crowded area around non-terrestrial planets, because even when we compare the more examined areas of Jupiter and Saturn to that of Uranus, the gap is still present even for them, and it is even greater. Now, Francisco is just the innermost irregular moon of Uranus. In total, there are currently 10 known irregular moons of Uranus, and somewhat unusually, there is currently only one group out of those 10. That is the Caliban group. Potentially, the reason as to why there is only one group is because the Caliban group is currently the only one which shows some indications that the satellites have a single origin. That is indicated by the fact that their average orbital distance is relatively similar, all of them on average between 7 and 8 million kilometers. They are also right next to each other, and on top of that, all 3 of them have very similar orbital inclinations. They have an inclination that is between 141.4 degrees and 143.9 degrees. This all points towards the idea that they formed out of an impact of a single object that sent debris flying, which got captured into orbit around Uranus. One thing that is very apparent on this list is that the orbits of irregular moons appear to be extremely tilted when compared to the regular moons. Now, it is true that they are extremely tilted relative to the equator of Uranus, but another reason for these very high numbers is because out of the 10 irregular moons, 9 of these have retrograde orbits, meaning they orbit in the opposite direction from the direction in which Uranus rotates around itself, and the orbits of retrograde moons is described from 180 degrees and lower. So considering how the orbital inclination of retrograde moons is described, we can spot one irregular moon that clearly sticks out. That is Margaret, the only known prograde irregular moon of Uranus. It has an inclination of 60.5 degrees and a diameter of about 20 kilometers, so it is on the smaller side compared to the rest of the currently found moons of Uranus. This moon is extremely eccentric, meaning its orbit is incredibly elongated, and on top of that, it is unstable. That is, its eccentricity changes. At one point in 2010, its orbit was the known most eccentric one in the solar system, but it still doesn't hold the place for the most eccentric orbit on average. Besides Margaret, one irregular moon that also sticks out as well, at least somewhat, is Sycorax, and that is due to its size, which is estimated to be somewhere around 160 kilometers. Potentially, it is smaller. However, it is also potentially even bigger than Puck. Sycorax was found in 1997, and like the rest of the irregular moons of Uranus, it wasn't found during the 1986 Voyager 2 flyby. Most of the irregular moons were found somewhere around the year 2000. The only big exception is S2023-U1, which is a moon that is a part of the Caliban group. This moon was found in 2023, as the name suggests. With a diameter of 8 kilometers, it is also the smallest known moon of Uranus. Finally, let's examine the most distant known moon of Uranus, Ferdinand. It is, on average, about 20 million kilometers away from Uranus. So, out of the 4 non-terrestrial planets in the solar system, Uranus's most distant known moon isn't as distant. For Jupiter, its own most distant known moon is 24 million kilometers away. For Saturn, it is 28 million kilometers, and for Neptune, it is 50 million kilometers. Now, Ferdinand, like these other most distant known moons, has a very eccentric orbit. So the distance of 20 million kilometers is just the average. Its eccentric, elongated orbit allows it to get as far away as 28.5 million kilometers. Now, the second most distant known moon of Uranus is Centibus, and although it does have a significantly closer average distance of 17.5 million kilometers, its orbit is also typically more eccentric, which allows it to get about as far away from Uranus as Ferdinand. One interesting thing about Ferdinand is that it needs 7.5 years to complete a single orbit around Uranus. And yet, despite the most distant known moons of Jupiter and Saturn being a lot more distant, they also need significantly less time to complete an orbit. So those were Uranus's most forgotten moons, which is, yes, pretty much all of them. However, they are certainly not all equally forgotten. The major ones obviously less so than the non-major ones. And that is not only because these non-major moons are not large spherical objects, but also because on top of that, we don't really have good photos of them. We just currently don't know how they look like up close. This photo of Puck is the best we got from the Voyager 2 flyby, and yet still, that image is also not very good. Even the Voyager 2 flyby of Neptune overall delivered better images of its non-major moons. The non-major moons of Jupiter were also overall imaged better through the Galileo spacecraft, and Saturn by far currently has the best photos available of its non-major moons, which were delivered from the Cassini spacecraft. So given that Uranus's non-major moons were imaged so poorly, Uranus has the most forgotten non-major moons. On top of that, even its major moons are overlooked when compared to the major moons of other 3 non-terrestrial planets. Despite Uranus's moons being so unexplored, there still aren't plans for the future missions that are certainly going to happen. There are proposals, of course, and NASA did show a clear significant interest in at least exploring Uranus itself, but whether or not a mission for the exploration of its moons is going to happen is still unclear. And even if we do get such a mission, probably the major ones are going to be mostly explored, with a few good images of the inner moons. But the distant, irregular moons could easily remain unexplored for centuries. That's because there are missions that show a greater promise. So obviously the irregular moons of Uranus are nowhere close to being a priority. Seemingly, it is also even going to be a challenge to get a better look at Uranus's major moons in the first half of this century.